Today we are going to pick up the other four properties of exponents using our division properties. So the first thing we'll talk about is a negative exponent. The negative exponent, if you have a negative exponent, it moves this whole thing to the bottom. And it makes it a fraction. You get 1 over a to the m. And this works as long as a does not equal 0 because you cannot divide by 0. So we're going to look at these. You have 4 to the negative 2. That negative exponent moves it to the bottom of a fraction. And we've done these before. And we can simplify that. 4 squared is 16, so we get 1 over 16. The next one we're just going to use a variable. We have x to the negative 3, so we pull that base down with the exponent and we get 1 over x to the third. Now the last one is I did on purpose because I want you to see when the exponent is negative and it's already in the bottom of a fraction. What we do with it is we move it up and we get w to the fifth. Whenever you move it across a division line, you're going to change its sign. Okay, your 0 exponent states that anything a to the 0 will give you 1 as long as a is not 0. So here's an example. We have 7 to the 0, that's 1, and we've talked about a lot of these when we talked about exponential equations and exponential graphs. Here we have x to the 0, that's 1, and this big old complicated thing to the 0 is just 1. So we're going to simplify each expression on example 1. The first one we have 6 to the negative 2. That becomes 1 over 6 squared. That negative requires us to move it to the bottom of the fraction. And then we can actually simplify this. 1 over 6 squared becomes 36. Our second one, we have something to a 0. So this portion becomes a 1. Now, 1 times anything is going to be whatever we have here, so I'm going to get rid of my 1 there and work with this 5 to the negative 4. 5 to the negative 4 becomes 1 over 5 to the 4th, and 5 to the 4th is 625, I believe, so it becomes 1 over 625. Okay, our last one again, we've got that 0 going on. So this becomes a 1, and 1 times 5 is going to be 5. Then we have this y to the negative 2. Because it's negative, it's going to pull it to the bottom of the fraction and give you y squared. That 5 will stay on the top. It could stay on the side, but we're just going to make it one fraction. Alright, I think we're on our third property, is the quotient of powers. And this says a quotient means that we're going to divide, so we have a to the m divided by a to the n, and notice that these bases are the same. If the bases are the same, we're going to subtract those exponents. And again, as long as a does not equal 0, because we cannot divide by 0. So we have two examples here. I like to show you these two on purpose. Our bases are the same, so we're going to look at those two exponents. The 4 is greater on top. We're going to leave that 3, and we bring the 4 here. It stays there, but we bring the 2 up and subtract. And this will give us 3 squared, which is 9. Another way to look at this is 3 to the 4 says we have 3 4 times. On the bottom it says we have 3 2 times. So because we have these, they line up, we can divide them out, and we're left with 3 times 3, which is 9. This might be easier if you write it this way. The only complication gets when we have like 3 to the 12th. I don't know if you really want to write 3 12 times, and that's why this rule is really handy. Okay, on the second one, I did this intentionally. I wanted you to see what happens when the power is greater in the denominator. When it's greater in the denominator, then we're going to bring this down. And because we move across that division line, we still will subtract. So we have x to the 7th minus 3. Now we have to have something on top of the fraction. Because we've moved that base, we put a 1 there. and this leaves us with 1 over x to the 4th. This is the same idea as the last one. I'll write it over here. You can have three x's on top with how many on the bottom? 7? 1, 2, 3, 4, 5, 6, 7. And 3 of these would cancel, but that would still mean you have a 1 on the top with 4 x's. And if you'd like to write it out that way, that's fine, but if you can remember this rule, it's a lot easier to use. So on example 2, we're going to go throughout this. Our x values are greater on top, so we're going to bring that 2 to the top and subtract. And when we subtract, we get x to the first or just x. On example B, these two values will divide out. They're exactly the same, and we could write a to the 2 minus 2, which is 0. A to the 0 is 1. Or we can just know that they divide out. So then we're just looking at the b values. We have b to the 3rd over b to the 5th. The 5 is greater on the bottom, so we're going to bring this exponent down and the base. And we get 1 over b to the 5 minus 3, which is 1 over b squared. Okay, the last one is a little bit more complicated. We try to get more complicated as we go. And this gives you some coefficients. When we're looking at coefficients, we are dividing. So because 25 doesn't divide into 5 evenly, we're going to look at the other way. Does 5 divide into 25? And it does. It divides 5 times. So I'm going to put the 5 on the bottom. Now I'm going to look at those exponents. I kind of drew on them. And I'm going to look at the x's. I have an 8 on the top, and it's greater than the negative 4 on the bottom, so I'm going to bring the negative 4 up. When I bring it up, I still subtract. So I have minus a negative 4. Because I have two negatives, I'm going to add them. And then with the y's, it's greater on the bottom, so I'm going to bring the 3 down, and then just simplify this. 8 plus 4 gives us 12. Over 5y, and 5 minus 3 is 2. And that is as simplified as that can be. And our last one is called a power of a quotient. This says that if we're dividing, that this power has to distribute to both terms, as long as b does not equal 0, because we cannot divide by 0. So here we have 2/3 to the 4th. You're going to distribute that 4 to both of those values, and we get 2 to the 4th. Remember, that's 2 to the 4th, not 2 times 4. And 3 to the 4th, not 3 times 4. So 2 to the 4th is 16. 3 to the 4th is 81. If these bases don't simplify, then this answer will not simplify. Okay, again, we're going to distribute that power to get x to the 3rd over y to the 3rd. And we're ready for some examples, and they get complicated. So whenever I see this, I always want to think of my order of operations. My order of operations says parentheses first, so we're going to work inside our parenthesis first and see if we can simplify. This 5 and the 6 do not simplify, so I'm going to leave them right where they are. The a values, I have a to the negative 2, and then I have a to the 4th, so the 4 is greater on bottom. So I'm going to bring that negative 2 down. When I bring it down, it's minus a negative 2, so I'll end up adding it. And then this b has a power of 1, so it's greater on top, and I will bring the negative 2 up, so it's 1 minus a negative 2, and 2 negatives will give a positive, so that becomes plus 2, and this is all to the negative 3. Now I'm going to go ahead and simplify that. That's 5b to the 3rd over 6a to the 6th, all to the negative 3. Now, because it's negative, that negative is, we can go ahead and distribute that to all of them. I'm going to have to write over here, I'm running out of room. 5 to the negative 3. When we distribute it, it's power to a power, you're going to multiply. So b to the negative 9 over 6 to the negative 3, and a to the 6 times negative 3 is negative 18. And if you notice, they're all negatives. So what's going to happen is this top of the fraction is going to come to the bottom, and the bottom is going to come to the top. So I'm going to go ahead and rewrite that. At the same time, I'm going to multiply. So this 6 to the negative 3 on the bottom would become 6 to the third. And I'm going to go ahead and multiply that out. 6 to the third is 216. And the a will move to the top, so we get a to the 18th. 5 to the negative 3 will move to the bottom, and you get 5 to the third, which is 125. And the b to the negative 9 will move to the bottom to become b to the 9th. And now we don't have any negatives in our expression. Okay, again, we're going to start within our parentheses here and see if we can simplify. Right here, the 7 and the 28 will simplify. 7 divides into 28 4 times. The w squared is greater on top than the negative 4, so we're going to bring up the negative 4. When we bring it, we subtract it, so it's 2 minus a negative 4, it becomes plus 4. And the z is also greater on top. And we're going to subtract the 2, and this is all to the negative 1. I'm going to rewrite this. W to the 6th, z to the third, over 4 to the negative 1. If you ever see negative 1, it's kind of just fun. What it will end up doing is it will flip your fraction. You can go ahead and distribute it. If you distribute it, it makes all the values negative, which then would make them change places. So if you see this negative 1, just know it's going to flip your fraction. You get 4 over w to the 6th, z to the third. Okay, hopefully that will help you with your assignment. It's 5-2, division properties of exponents.